Alright, let's go ahead and take a look at the Unit 6 test review. This is the second page. So number 10 for the rectangle E, F, G, H, close it. If EF is 4x minus 6, and HG is x plus 3, and we know that EH is 3x plus 3, find the measure of EF. Okay, so since this is a rectangle, it is a special type of parallelogram, and since it's a parallelogram, it has those properties. So a rectangle has properties of a parallelogram. So opposite sides are congruent. Opposite angles are congruent. If one angle is right, then all angles are right, and so on and so forth, right? So really, we want to know, or we really want to use the opposite sides are congruent property. So these two expressions, or these two sides, are congruent. They are equal to each other. This is to throw you off. So please make sure that you are labeling your quadrilateral in this case. 4x minus 6 equals x plus 3. So 3x is equal to 9. So x is equal to 3. But the question doesn't ask to find x. That's helpful to find x. We're asked to find the measure of EF. And EF is 4x minus 6. So replace the x with 3. So then I'm going to simplify. So I get 6. That's the measure of EF. For the same rectangle EFGH, if the measure angle GEH, so this is, where's GEH? GEH. So really I'm looking at this particular angle. We know that that's 62. We're being asked to find the measure angle. Let me use a different color. Find the measure angle EK. H. Okay, so it's this angle that I'm looking for. So this is something that you have to understand about a rectangle. Okay, let me just go ahead and rewind. I'm gonna erase this. Remember, with a parallelogram, right? Opposite sides are congruent. Opposite angles are congruent. The consecutive angles are supplementary. If one angle is right, then everything else is right. And the diagonals bisect each other. That's the important one here. Diagonals bisect each other at a midpoint. So this is saying, okay, well, since I have the midpoint, it's the midpoint of EG. So I put one segment here and one segment here. Okay? Now, the question is, since we know that K is also the midpoint of HF, how many tick marks do I put here? Well, I actually put 1 because you need to know that the diagonals of a rectangle, this diagonal here and this diagonal, are congruent, so they do have the same measure. I don't put 2 tick marks because, once again, the diagonals here are congruent. Okay? So we label that GEH. We label that GEH is 62 degrees. Okay? And we know that we have to figure out what this angle here is. We're going to put a question mark. Actually, no. Instead of putting a question mark, let's call it X, because that's our unknown. We don't know what that is. So what is this angle here? We don't know what this angle is. But we do know that what we're dealing with is an isosceles triangle, because we can see that these 2 tick marks indicate that this triangle here is isosceles. Okay? And we're going to have to refer back to our isosceles triangle theorem, which they said if 2 sides are congruent, then the angles opposite to each other are congruent. So if this here is 62, this angle here is 62. Okay? So then, okay, great. I know that those two angles are 62. What is the value, which we called x, the measure angle EKH? So this is what I'm going to go ahead and do. I'm going to do 62 plus 62. Okay, there are two 62s. And then I'm going to add the x and set that equal to 180 because the sum of the interior angles of a triangle is 180. And then I'm going to combine the like terms here. And 62 plus 62 is 124. And then I'm going to bring down the x, and I set that equal to 180. Minus 124 on both sides, so that's going to give me 56. So x is equal to 56, and that same x is the measure angle EKH, which is 56 degrees, okay? Alright, here we go. If QRST is a parallelogram, what is the value of x, and what is the measure of CR? Okay? So, QRST. QRST, close it, so that's how you're supposed to read it. What is the value of x, and what is the measure of CR? Okay, so, what do I know? This is a parallelogram. Again, one of the properties of a parallelogram is that when the diagonals do bisect each other, they create a midpoint. So that means that C is the midpoint of segment TR. Okay? And then I like how this 12x minus 8, it's pointing at what segment I am looking at. And I know it's a little blurry, but hopefully this video does help and clarifies everything. So that means that, okay, well, here is my 12x minus 8, it has that one tick mark, and 14x minus 34, it has that one tick mark. They're congruent. So I'm going to set them equal to each other. And then I get negative 8 equals 2x minus 34. Then I'm going to add both sides by 34 here. I get 26 here. Let me go ahead and show my steps. Add the 34 on both sides, okay? And then that's negative 8 plus 34, which is 26. Set that equal to 2x. I'm dropping the 2x down. So 13 is equal to x. That's great. 13 is equal to x. So what is the value of CR? Well, CR is currently 14x minus 34, right? So 14x minus 34, which is 14 times 13, because that's x, minus 34, and that's going to give me 148. That's how long that side is, or that segment is, okay? Not degrees. We only put degrees only if we're dealing with dealing with angles. So no degree signs there. ABCD is a rhombus if the measure EB is 9. So here's EB. That's 9. And AB is 15. And know that the measure angle ABD is 55. Okay, so find each measure. Let's go ahead and find AE. And since we're dealing with the rhombus, know that with the rhombus, right, the diagonals are perpendicular, meaning that they intersect at a 90-degree angle. So here, the diagonals, they will intersect at a midpoint. That's number one, and they also intersect at a 90-degree angle. So I'm going to go ahead and draw my square, which represents 90 degrees. And let me go ahead and erase this 55 degrees. So I'm only focused on one thing at a time. So here's my triangle. This is 15 and this is 9, and then I'm looking for the measure of AE. So I don't know what this is. We'll call it C. So in this case, no, let's not call it C. So, my bad. I don't really want to call this C. I want to call this, I'm going to call this X, actually. We are dealing with a Pythagorean theorem, okay? Because know that you're dealing with a right triangle. And if a right triangle, then you're going to be using a squared plus b squared equals c squared, where c is the hypotenuse. Which one is the hypotenuse? This is the hypotenuse. It's always across from the 90 degrees. So the side here, right? If we look, here's the angle, here's the side. Across from the 90-degree angle is the hypotenuse. Okay? So then let's go ahead and replace C, because this is C, right? This is C. So I have a squared plus b squared equals 15 squared. 15 squared, right? And then what the heck is a and b? Well, a and b, a can be x or b can be x. It doesn't really matter. So I'm going to say x squared plus 9 squared equals 15 squared. Okay, so a and b, it doesn't matter which one. You can choose whatever. You can choose this or this, as long as you know that the hypotenuse is across from the 90-degree angle, and that is c. That's so important. Now, our goal here is to find this length, right? We represent that as x, okay? So it's basically like what we've been doing since Algebra 1. We're solving for x in this case. This 9 squared is in the where. I don't care what 9 squared is, but I want to get it away. So I'm going to go ahead and subtract both sides by 9 squared, okay? And I get x squared equals 15 squared minus 9 squared. Y'all, please do not do 15 minus 9 and then say that is 4 squared. Don't do that. Don't do that. Just do 15 squared minus 9 squared, and then you're going to take the square root on both sides because you want to eliminate the exponent of 2, and by doing so, you have to take the square root on both sides. And then we're going to go ahead and use our handy dandy calculator. I'm going to use Calculate 84, which you can download on the App Store or whatever store you're going to be done, wherever you get your apps from. I press second, and I take the square root sign. So second x squared is what you want to do to get that, square root sign. And I'm going to input 15 squared minus 9 squared, and look, if I press enter, I get 12, okay? So that's the answer. So the square roots in the exponent 2, they go away, so I get x equals 12 from the calculator. So what does that mean? That means that this is 12, that is 12, and that is the measure that I'm looking for. AE is 12, okay? So that's 12. And then ABD is 55. So I'm going to go ahead and go back and say ABD is 55. Right now I'm going to go ahead and erase that 55 at the beginning because I want to focus on one thing at a time. Right, so that is 55 degrees. What is the measure angle BDA? So B. Whoa, ABD. What is the measure of BDA? Okay. So, all right. Let me think. We know, because I want to figure out what this is now. Okay, I really do. I really want to figure out what this thing is. I know that this is 55. So doesn't that mean that this is 55 as well, y'all? That's 55 degrees. And let me go ahead and tell you why. Okay. This is a rhombus, right? That means that all the sides are congruent. And if I were to focus particularly, so let me go ahead and erase this. Let's erase this. I'm going to focus on this. And since I erased the tick mark, it should be there. So this is 55, and then this is what I'm looking for, and then it has these 2 tick marks here. Okay, So this is basically an isosceles triangle. Okay, this is basically an isosceles triangle, and you have to remember, if two sides of an isosceles triangle are congruent, then the angles opposite to each other, they have to be congruent as well. So if this is 55, then that means that this has to be 55 degrees as well. So that's my justification for that one. Okay? Alright. Alright, I am back. I am going to look at number 16. Quadrilateral ABCD has vertices A, B, C, D. So those things are my points. Sorry, I'm trying to pull up the key. I don't know where I put the key at. Alright, here we go. So this is a quadrilateral, and my goal here is to, number one, graph the points. So -3, 4, that's A. And then B is 4, 4. C is 7, -1. And then D is 0, -1. Okay, so here's C and here's D. And then I'm going to go ahead, since it's a quadrilateral with meaning 4 sides, let's connect those dots. Okay, so let's go ahead and find the slopes. I love how it's already laid out for me. Okay, it says find the slope of AB. Find the slope of AB. So here's A, here's B. Remember, the slope formula is m equals y2 minus y1 over x2 minus x1. So let me call this x1, y1, x2, y2. So the slope of AB is y2 minus y1 over x2 minus x1. So that's 0 over 7. So really, that's just 0. Okay, so that's the slope of AB. Let's find the slope of DC. So trying to find the slope of DC here. We found AB, that's 0. Let's find the slope of DC, and yes, I can tell that this is a 0 slope. I'm going to calculate it just to verify with y'all. So call that, how should we call this? We call this x sub 1, y sub 1, x sub 2, y sub 2. I know it says DC, and I did, x sub 1, y sub 1 for C. It does not really matter. You can call this, you can put x sub 1, y sub 1 for D. It does not really matter, as long as you're consistent and you call that, x sub 2, y sub 2 for C. But, this is already what I'm going to label, so, we have y2, so we have y2 minus y1 all over 0 minus 7, -1 minus -1. That negative times a negative, y'all, remember, that's a positive. So you're really dealing with -1 plus 1, which is 0. And then 0 minus 7, that's -7, but really that's 0. Okay? So that means that since this here has a slope of 0 and this here has a slope of 0, that's really parallel. That means those opposite sides, the top and bottom are parallel. And then now I gotta go ahead and find the slope of AD and then BC. Okay? So the slope of AD, so here's A and here's D, x sub 1, y sub 1, x sub 2, y sub 2. So y2 minus y1 over x2 minus x1. So negative 5, 0 minus negative 3, 0 plus 3. So it's negative 5 over 3. The slope of BC, so here, I'm going to erase this. Here's B, here's C. X sub 1, y sub 1, x sub 2, y sub 2. y2 minus y1. y2 minus y1 over x2 minus x1, negative 5 over 3. So that means that the left and right are parallel. Okay, we said that the top and bottom are parallel, and now we show that the left and the right are parallel. So based on your answers above, is the quadrilateral a parallelogram? Yes. Okay, remember, with a parallelogram, the definition of parallelogram is that it is a quadrilateral with two pairs of parallel sides. Okay, so how do I justify my answer? I can say, see the slopes, those opposite sides are parallel. Okay? See the slopes, opposite sides are parallel. That's a great justification here. Alright, I will see you for the next page.